Hey everyone, this is Sahiti on behalf of Edureka and welcome to this session on Git tutorial. So without wasting any further time, let's get started with this session now. So first let's look into all the topics that we're going to cover in today's session. We'll start today's session by understanding why do we need version control and then get into what exactly version control is. After that, I'll tell you the different types of version control systems and then discuss the tools. After discussing the tools, I'll tell you why Git wins over the other top tools in the market and then I'll tell you what exactly Git is with its workflow. So finally, after discussing so much of theory about Git, we will move on to the hands-on part where I'll be running all the commands related to the Git and you'll know different operations related to Git. So now let's get started with the session. So first, let's consider a scenario of a company here. So Alice is a developer of a company and deals with deploying new features in the UIs created for the clients. So here, she implements a new feature in the UI hoping that her client would like it. But what happens is the client doesn't like the feature and asks her to remove the feature. So as a result, she deletes the code. But after a few days, the client calls her back and asks her to put the feature back. So now, since the company did not have the version control system, she has to do all the hard work again and then rebuild the code and then deploy it in the UI design. But in such situations, so if the company had adopted the version control system, then Alice would not have to rebuild the code. Instead, she would just pick up the code from the version control system and deploy it in the UI again, right? So wasn't it very simple with the version control system? It is, right? Now, what exactly is this version control system? But before I tell you what exactly version control system is, let me show you what was the chaos caused without the version control system. Well, without the version control system, there was no collaboration between the team. So basically, there were no records maintained. Nobody knew who made the changes and where was the change made and when was the change made. So the team of developers working on a particular system made their changes by themselves. Now, secondly, once saved, all the changes are permanent and cannot be reverted back. So once the developer makes change in their code, then that change was permanent. Nobody could revert it back even if it was wrong. So this was one of the main disadvantage of not having a version control system. Not only this, but also downtime also occurred due to faulty updates. That was because there was no backup maintained. In any situation, if their code crashed, then the complete system would go down. So looking at the above problems, many organizations decided to come up with the version control system. So let me tell you what exactly is version control system. Well, you can think of a version control system as the management system that manages the changes that you make in your project till end. So the changes that you make might be some kind of adding new files or you're modifying your folder or it could be any kind of changes, right? So what the version control system does is that every time you make a change in your project, it creates the snapshot of your entire project and saves it. And then these snapshots are known as versions. Now, if you have a problem with the word snapshot, just consider that snapshot is actually the entire state of your project at a particular time. That means it will contain what kind of files your project is storing at the time and what kind of changes you have made. So this is what a particular version contains, right? Now, if you see an example here, let's say that I've been developing my own website. So let's say in the beginning, I have a web page as index.html. After some time, I add another web page of about.html. So in this about.html, let's say I've added some kind of pictures and some kind of text, right? So what exactly the version control system stores is that it detects that something has been changed, right? Something has been modified. For example, if you see here in the about.html, it is showing that a photo has been added. So let's say that after a few days, I've changed the entire page layout of about.html. So again, with the version control system, we will detect that some kind of change has happened and that will say that about.html has been modified. And you can consider all these three snapshots as different versions. So when I only have my index.html and I do not have any other web page, this can be considered as my first snapshot. And then when my about.html has been created and some photos have been added, this can be considered as my second snapshot. In the similar way, Once the about.html has been modified, that is, the complete layout has been modified, that can be considered as my third snapshot. So the three snapshots could be identified as version 1, version 2, and version 3. So guys, this was basically how a version control system stores different versions. So I hope that you've understood what are versions and what is version control system. Now, let's get into the different types of version control system. Well, to say that, there are three types of version control systems: the local version control system, the centralized version control system, and the distributed version control system. So when you talk about local version control system, the local version control system is where many developers are working on the same version. Now, coming to the centralized version control system. Centralized version control system consists of a central server. So it basically stores all the files and enables team collaboration. It uses a central repository which stores all the files in that repository so that users can access it. So this is what happens here, guys. Every developer has a working copy. If there are n number of developers working on a single repository, then there are n working copies. The moment they want to make a change in their source code, they can make change in their shared repository, and then they can also update their working copy by pulling their code from the shared repository to their working copy. So the repository that you see on the screen indicates a central server that could be local or remote and is directly connected to each of the programmer's workstation. So the central repository is connected to each and every working copy. Now, every programmer can extract or update the workstation from the code present in the repository, or can even make changes to the data or code present in the repository. So every operation is directly performed on the central server. Now, this may seem very convenient to maintain a single repository, but it has many drawbacks. Before I tell you what are the drawbacks, let me tell you what advantages it provides. So every time you commit, there will be a commit ID associated to it, and also there will be a commit message associated to it. So basically, you'll know who is making the commit at what time and what has been changed in the code. So you can always revert back to that particular commit and then make the changes again. Now, let me tell you some disadvantages about centralized version control system. First of all, it is not locally available. That means you always need to be connected to a network to perform any action. Since everything is centralized, so just in case because of any calamity the central server goes down, then it results in the loss of data for the complete system. This was one of the main reasons why centralized system is not used in many industries. Now, let's talk about distributed version control system. Now, these systems do not necessarily rely on central server to store all the versions of the project file. So, in distributed version control systems, every contributor has a local copy or the clone of the main repository. So that is, everyone maintains the local repository of their own and then contains the files and the metadata present in the main repository. So in simple terms, everybody has a copy of the remote repository. As you can see in the diagram, everybody maintains a local repository on their own and they can commit and update their file without any interference, right? So they can update their local repositories with new data coming in from the central server by an operation called pull, and then affect the changes to the main repository by an operation called push, right? So if you want to pull the data from the remote repository to your local repository, then you use the pull operation. And then if you want to make the changes from the local repository to the remote repository, then you use the push operation, right? So now that I've told you what centralized and distributed version is, all of you might be thinking on the advantages of distributed version control over the centralized version control system, right? So basically, act of cloning gives you the main advantage. So now let me tell you how. All operations apart from push and pull are very fast because the tool only needs to access the hard drive and not the remote server. So with this functionality, you do not need the internet connection always. Now, committing new changes can also be done locally without manipulating the data on the remote repository. So just in case if you want to make any changes, you can take feedbacks from the other developers, and then once you make the changes, you can review them once and then push those changes to the remote repository. Now, if the central server gets crashed at any point of the time, then the lost data can be recovered from any of the local repositories. So this was not the case in the centralized version. If at any situation the central server gets crashed, then the complete data would be lost. Apart from that, since everyone has a full copy of the repository, they can share changes from one another, right? So, as I told you before, if they want any feedback before they push the changes to the remote repository, they can take the feedback from other developers, make the changes, review it, and then push those changes to the remote repository. So guys, these were some ways by which the distributed version control system was a better option than a centralized version control system. So now that you've got a gist about what version control is and what are its various types of systems, let's look into the tools that offer version controls. Well, the top leading tools in the market are Git, Apache Subversion, concurrent version systems, Team Foundation servers, Mercurial, etc. But out of these tools, we can clearly see on the trends that Git wins over the other tools. But why does Git win over the other tools? So let's look into it. Well, Git offers many features due to which it wins over the other tools. So let's start with the features of Git. So the first feature on the list is Git is economical. So Git is released under the GPL's license, it is for free and it is open source. So that makes Git economical. Next, Git is non-linear. Now, when you talk about non-linear, Git supports non-linear development of software. Now, when you're working with Git actually records the current state of your project by creating a tree graph from the index. And as you know, that tree is a non-linear data structure. It is actually in the form of a directed acyclic graph, which is popularly known as DAG. Next, coming up with the list, we have Git providing the concept of snapshots. Git records the changes made to the file rather than changing the file itself. So as I told you in the example before, if there was a web page added and there were some photos added in it, Git would maintain a snapshot of that photos were added in the new web page. Now, after that, in the list, we have Git offering a distributed architecture. So as Git is a distributed version control system, every user has his own copy of repository data stored locally. So no changes are made to the central repository unless and until they are pushed from the local repositories. So this is one of the biggest advantages why Git wins over the other tools. Next in the list, we have Git offering speed. Git offers a light parsing speed when compared to the other version control tools. Not only does Git offer speed, but Git is also robust. When I say robust, that is because every task is undoable. So just in case you commit some changes and you want to revert them back, then definitely you can do it. So you can revert back to any action that you have performed even if it is 10 actions back. So that's how Git also offers integrity. Well, as I said, Git records everything. So no changes can be made without Git recording it. And finally, in the list, we have branching. Well, Git offers branching. So every collaborator's working directory in itself is a branch. So Git offers non-linear development, that is the parallel development, and it also offers branching. So guys, these were some features of Git because of which Git wins over the other tools. Now that I've told you so many features about Git, let me tell you guys what exactly Git is. Well, Git is an open source distributed version control system which records changes made to the files, laying emphasis on speed, data integrity, distributed and non-linear workflows. So Git is the tool that you require to perform all these operations, and don't worry, I'll be telling you all about how to perform this operation for using Git later in this tutorial. For now, just think of Git as the tool that you actually need to do all kind of version control systems. Okay, so Riaz has a question here. Can two people contribute to a local repository? Well, a local repository resides in your local machine. So now if two people are using the same machine, you obviously do not want that because every developer has got their own machines. So there's no use of sharing a local repository. The main concept of local repository is to work in isolation. But if you want to create a subgroup, and let's say that these two collaborators are working on same kind of application, but that is different from the work of these three collaborators, then they can subgroup themselves, right? So let's say if these three want to maintain a repository before they commit their changes to the remote repository, and these two want to maintain a repository before they commit the changes to the remote repository, well, they can do that. You can place any other repository wherein a few people can collaborate into that repository. So for now, the local repository here is that repository that actually resides in your local machine. So Riyaz, is the answer clear to you? Okay, I've got a yes. So now let's move on. Alright, I've got one more question here, guys, from Ayushi. Well, the question from her is that how can I share the commits with only a specific person without committing in the remote repository? Well, the answer is no. Well, actually, you cannot commit something in other person's repository and you can only commit in your local repository. So basically, the remote repository is where everyone can see what changes you have made and what kind of changes you have made in the project. And in the local repository, you're the only person who has access to your repository. So the changes that you've made in the local repository is only seen by you. Until and unless you push it to the remote repository, nobody else can see it. But since all of you are connected over a network, you might take advice from your fellow collaborators, but you can actually not show your commits directly to him without committing it to the remote repository. Alright, Ayushi, is the answer clear to you? Okay, I've got a yes. So now let's move on to the workflow of Git. So what do you understand by Git workflow? Well, the Git workflow is used to manage your project effectively. So basically, if you work with a set of guidelines, then it obviously increases your consistency and productivity. Now, let's discuss each and every component in the Git workflow. Starting with the remote repository is the server where all the collaborators upload the changes made to the files. So all the changes that each and every collaborator makes is uploaded to this remote repository. Next, we have the local repository. As I mentioned before, the local repository is the user's copy of version database. So the users access all the files through their local repository and then make changes. Once they have a set of changes, they push the changes to the remote repository. So if there are n number of people working on an application, then there are n local repositories and then each one of them can make changes in their local repositories. Once they are done, they can push all these changes to the remote repository. Then we have the working copy. The working copy is nothing but the user's active directory. In this, the user modifies the existing files and creates new files in the space. So basically, this is the area where the user makes changes. So Git tracks these changes and compares it to the local repository. Next, we have the staging area. So the staging area is a place where all the modified files marked to be committed are placed. So basically, once you make the changes and then you want to commit these changes, before committing, you put them into the staging area. So basically, you can visualize this place as the place between the working copy and the local repository. Now, coming to the commands used to perform these actions in Git, the clone command creates a copy of an existing remote repository inside the local repository. So basically, this command is used to make a copy of the existing remote repository. So anytime you want to create a copy of the existing remote repository, then you use the clone command. Next, you have the commit command. The commit command commits all the files in the staging area to the local repository. After that, we have the push command. The push command pushes all the changes made in the local repository to the remote repository. So anytime you have a set of changes ready, then you can use the push command to push all the changes from the local repository to the remote repository. After that, we have the fetch command. The fetch command collects the changes made in the remote repositories and copies them to the local repository. So any changes that you make in the remote repository, the fetch command copies these changes and puts them into your local repository. Well, let me tell you that this command doesn't affect our workspace. That is a working copy. Now, the pull command is similar to that of the fetch command. It gets all the changes from the remote repositories and copies them to the local repository. So basically, pull merges those changes to the current working directory. So guys, I hope that you're clear with the components for the Git workflow and the commands used for it. So now that you have a basic idea of Git workflow components and the commands used, let's discuss the workflow now. So as you can see the diagram on the screen, I'm going to explain the workflow of Git through this diagram. So suppose I'm a developer and this is my working directory. Now what I want to do is, I want to make some changes to the local repository. So since it is a distributed version control system, I have my local repository as well. Now, what I'll do is, I'll perform the git add operation here. Now, because of this git add operation, whatever was there in the working directory has been put into the staging area. Now, you can visualize the staging area as the place between the working directory and the local directory. Once I have all my uncommitted changes in the staging area, I want them to get committed into the local repository. So for that, I'll perform the git commit option and then I'll commit all the changes to the local repository. And once I'm done with all the set of changes, I'll go ahead and I'll push these changes to the remote repositories as well. After that, you can perform the git pull option to add whatever is there in your remote repository to your local repository, and then you can perform the git checkout command to add it to the working directory as well. It's really simple, right? So you just have to make changes in your working directory, add them to the staging area, and then commit them to the local repository. Once you're done, you just push all these changes to the remote repositories, and whenever you want whatever is there in the remote repositories, you just simply pull whatever is there in your remote repository to the local repository and then also copy these changes to the working directory by using the git checkout command. So guys, that's how simply Git works. Well, let me tell you that Git not only provides a simple workflow, but it also provides parallel development or non-linear development. Well, when I say parallel development, I mean various operations that Git provides. Well, Git provides three main operations: branching, merging, and rebasing. With rebasing, various other concepts come like reverting and resetting. So first, let's talk about branching. Well, in simple terms, how do you understand branching? Well, you can just assume it like a tree. A tree has various branches and it has one master branch, that is the stem. Similarly, you can think of branches like a pointer to a specific commit. Let's say that you have made changes in your main branch. And now remember, whenever I say main branch, I'm talking about the master branch. Right? So the master branch is our main branch. Now, this master branch contains all the codes. So let's say you're working on the master branch and you've just made a change and you've decided to add some new feature onto it. So you want to work on the new feature individually and you don't want to interfere it with the master branch. So for that, if you want to separate the master branch from the feature, then you can actually create a branch from this commit. So basically, if you want to work on any feature specifically and you do not want the master branch to get involved with it, then you create a new branch on that commit. Alright? So there are two kinds of branches, that is mainly the local branches and the remote tracking branches. So your remote tracking branches are the branches that is going to connect your branches from your local repository to the central repository. And the local branches are something that you only create in your workspace and that is only going to work with your files in the local repository. So obviously, branching is an integral part of version control system. Unlike the other version control systems, Git does not create a copy of existing files for a new branch. It just points out to the snapshot of the changes you've made in the system. So it's really simple. So now moving forward to the next operation we have is merging. So now, if you're creating branches and you're developing a new feature and you want to add this new feature, then you have to do an operation called merging. Merging combines the work of different branches all together, and it's really important that after you've branched off from your master branch, always combine it back at the end after you're done working with the branch, right? So what I'm trying to say is, once you create a branch and then you're done working with that particular branch, you have to merge it back to the master branch. So in simple words, merging integrates the changes made in different branches into a single branch. So it's really simple. So just imagine a master branch has 5 to 6 new branches. So once you're done working with all these 5 to 6 branches, you just have to merge them to the master branch. Now next in the list, we have rebasing. Rebasing is also another kind of merging. So the standard rebase is that it actually solves the same problem as merge, and both of these commands are designed to integrate changes from one branch into another, and the fact is that they just do it in different ways. Now what does rebasing mean? If you see the workflow diagram here, you've got a master branch and you've got a new branch now. So when you're rebasing it, what it does is you can see in this workflow. So it's got a new branch and your master branch, and when you're rebasing it, instead of creating a similar commit which will have two parent commits, what rebasing does is that it actually places the entire commit history of your branch onto the tip of the master. Now you can ask me, why should we do that? Like, what is the use or what is the major benefit of using rebase? So basically, rebase offers you a much cleaner project history, And also, rebase is used when changes made in one branch need to be reflected in any another branch. So any change that you make in any particular branch and that change needs to be reflected in any another branch, then you need rebase. So now that you've understood what parallel development is and what Git offers regarding the parallel development, let's move on to another important operation about Git, that is stashing. Now, Git stashing is a way of creating a checkpoint for non-committed changes. It saves all the changes to a temporary location so that the user can perform other tasks such as switching branches, reverting, etc. These changes can be reapplied anywhere. So as you can see in the diagram on the screen, this is the temporary location to which the user can save all the uncommitted changes and then perform actions such as reverting and switching through branches here. So whenever the user wants some changes which are stored in the temporary location, he can just apply these changes anywhere. So now that I've told you so much about version control systems and Git and different operations in Git, let's move on to a hands-on part where we'll be performing all these operations. So we have a company where 3 developers are working. Now, they want their company to have a better source code management. So whenever I say source code management, I'm referring to the version control system. These developers want a better source code management because the earlier tool had the tendency to save redundant code. So they did not want redundant code in the system. So they faced issues such as when multiple developers were working on the same block of code, there were a lot of changes happening and nobody knew who was making. So the solution to this problem is to move the code of this company to GitHub and use Git. So how do we do that? Well, we're going to create a local repository and then move the entire code base into it. Then we're going to create a new branch for this new feature that you want to add to the application. Then we will merge back this created branch with the master and then we'll create a remote repository. After that, we'll see how rebasing and stashing is performed and then finally push this local repository to the remote repository. Okay, so now let's get started with the hands-on. Alright guys, so let me go to the Linux operating system where I've installed my Git. Just in case you want to know how to install Git, then you can refer to the Git installation video which is mentioned in the description box below. So now let's get started with the hands-on. So our first task is to create a local repository on the local machine and then also to create a repository in the GitHub account. Let me just create a repository. So let's say I create a new folder with the name Git tutorial hands-on. And then I go back to the GitHub account and then I create a new repository. So this is my GitHub account. After creating the local repository on your local machine, you also have to create the remote repository on the GitHub website. So guys, this is my account. If you want to log into the github.com, you just have to type github.com and then you have to fill in the sign-in details. Once you're done with that, you'll be redirected to this page and over here, you can add new repositories. So let me just add a new repository. So you have to give the repository name. So let's say I give the repository name as Git example. And then I'll choose a repository to be public. If I want this to be private, then I have to buy a license. I'll just choose the option public and then I'll click on create repository. So you can see that my repository has been created here. Now what we have to do is we have to make the changes on our local repository and then we have to commit these changes to our remote repository. So now let's get started. Let me go back to my local repository and over here I'll put in the code base for the company. So let me just put in the code base. So let me just go back to downloads, copy this, go to documents and let me paste it here. So that means all the source code for this company is present in the local repository. Now what we have to do is we have to make changes in this repository and then commit these changes to our remote repository. So for that, let me just go to this folder. So for that, let me just open the terminal. So I'll open the terminal. Now in this terminal, we have to go to this particular local repository. So let's just type in the path name. Once you go into this folder, let's just list all the items that are present in this folder. Well, you can see that the sample project, that is the sample code for the company. So now let's go to this particular folder and see what all is there in it. So let's use the command ls-a, which will basically list all the files and folders that are present in this particular folder. So you can see that it has folders for CSS, fonts, image, and it has a particular file that is index.html. Alright. So now what we have to do is we have to initialize Git on this particular folder. So let's just go back to this Git tutorial hands-on folder and then let's initialize Git here. So for that, I'll use the command git init. So this command will basically initialize Git for this particular folder. Well, you can see an output that initialized empty Git repository in this particular folder, right? So basically, this is a working copy. Now what we have to do is we have to basically add this folder to the staging area. So let's just use the command git add to add this folder. So as you can see that we have to use the file name to add the folder. So we have to be really specific, right? So we'll use git add space dot. Dot means all the files and folders in this particular Git tutorial hands-on folder would be added to the staging area. So that means our folders have been added. Now we have to commit it. So for that, if you want to commit the folder, then you have to just use git commit. So when you use the git commit command, you can see that it asks us to enter a commit message. So let's just say I enter the commit message as this is the first commit for the project. And then I'll press on Ctrl X and I'll save this file. So you can read the first commit message as this is the first commit for the project, right? Now, if you want to check on which branch are you working and if there's anything that you have to commit or not, you just have to type in the command git status. So with this command, you'll know that you're working on the master branch and you have nothing to commit. Now, if you want to know how many commits have happened and what are the changes that have happened in the commit, then you just have to type in the command git log. So you can see that there's a particular commit ID associated with each commit. And then you also know the author, date, time, and what has been changed, right? So anytime you enter a commit message, it will consist of what has been changed. So the commit message will basically tell you what has been changed in the previous folder. Now what our developers wanted was they wanted to add a new feature and then merge it back to the master branch. So for that, to add a new feature, as I already told you, for each feature to be dealt with, we need a particular branch, right? So to create a new branch, we'll use git branch and the branch name. So suppose I put the branch name as feature 1. So I'll type in feature 1 and this will create my branch, right? Now, if I want to see how many branches are there, so I'll just use the command git branch to see that there is only one particular branch, that is feature 1, and then we are on master. So as you can see that master has been highlighted, that means we are presently working at master, right? If you want to work on this particular branch, you have to go on that branch, right? That means your head has to go from master to that particular branch. So to do that, you just have to type in git checkout command with the branch name. So here I'll put it as feature 1 and then click on enter. So you will see an output that switched to branch feature 1. That means our head is on feature branch, right? So let's just check if it's true or not. So let me just type in git branch. And then you can see that feature 1 has been highlighted. So let's say we want to edit something on this new branch, right? So let me just open one file. So let's just open that HTML file that we saw in the beginning. Okay, so it was my bad that I did a mistake here. I just opened a new file in Git tutorial hands-on. Our aim was to open the index.file that was there in the sample project, right? So we have to go to the sample project folder first. So let me just type in sample project. And then inside this, let's open the index.html file, right? So let's just open index.html. Well, you can see the HTML document for the company, right? So let's just say we change something here. So let's say I add a comment. So let me just type in the comment. So suppose I type in the comment as this is a really important file. And then I close this comment. And also I make changes in the description lines. So suppose I change Azure DevOps project to AWS DevOps project. And I also change the second line to be AWS again. So after I'm done with these changes, I'll just save this file, right? So I've saved this file. Now let's just close this file. So after the file is closed, let's see what were the differences between the file that was in the local repository and that was in the working space. So for that, we'll just type in the command git diff to know what changes have been made, right? So the lines in the green section have been changed, right? So you can see very clearly that there was a comment added, and then previously it was Azure and now it is AWS. And similarly in the second line, we have changed the word Azure to AWS. So guys, that's how with this command we know what changes have been made, right? Now just in case if we want to add these changes to our local repository, we have to use the command git add with the file name. So here the file name is index.html and then I'll click on enter. So once this is done, I'll just commit these changes. When you can commit these changes, then you can mention the message, right? So here we'll mention the message that a comment was added and also Azure has been changed to AWS, right? Once it is done, we'll just save this and then you can see that one file has been changed and there are 3 insertions, that is 1 comment and 2 description lines have been changed and 2 words have been deleted. So guys, these were some changes that were implemented on the feature branch. Now let's go back to the master branch and then let's merge this feature branch with the master branch. So for that, we'll just use the command git checkout master to go back to the master branch. So once you've gone back to the master branch, we're just going to merge the feature branch with the master branch. So for merging, we'll use the command git merge and the branch name, right? So since the branch name is feature 1, we'll put in as feature 1. So let's just click on enter. So you can see that it has been updated and the files have been changed in the master branch also, right? So since we're working on the master branch now and you want to check if the changes have happened or not, so let's just open the HTML file that we changed. So let me just type in. So let's just scroll up and you can see that there's a comment added here and it has been changed to AWS here. And similarly, even in the description line too, it has been changed to AWS, right? So that means our changes have been successful in the master branch. Now guys, sometimes what happens is if 2-3 people are changing in various branches and they're updating simultaneously in the master branch, then a merge conflict can happen. Now, a merge conflict is resolved manually. So there are various merge conflict tools that you can use so that you know which changes to keep and which changes you do not want to keep, and you choose between the changes and then finally merge the changes that happen to the branches to the master branch. So now moving on, let's close this file. Now, what we're going to do is we're going to deal with the remote repositories. So to deal with the remote repository, you just have to type in git remote add and a variable name. So let's say I put the variable name as origin, and then you have to mention the link of your remote repository, right? So let me just go back to my remote repository. Let me just copy this link and paste it here. Once it is done, I'll just click on enter. Now let's just use the command git log again to see how many commits have we made and what are the changes that we have made. So let's just do that. Okay, so clearly we can see that we have made 2 commits. The first commit was a simple commit, and in the second commit we have made a change. In the second commit, it is very clear that we've made the changes on the feature branch and then we have merged the master with the feature branch, and presently the head is at master. That means we're working on the master branch now. So that's how you can create branches and then you can merge them. Now the developers wanted to push this code to the remote repository, but before that, let me show you how to perform the stashing and the rebasing operations. So for that, let's create a new branch. So let me just type in git checkout -b feature 2. So the -b over here would automatically create a new branch and then it would also change the head to that new branch. So this feature 2 is the new branch name. So that's a shortcut of how you can create a new branch and also change the head to that particular branch, right? So you can clearly see that the output shows switch to a new branch feature 2. Now what we're going to do is let's edit files in this feature branch and then I'll show you how stashing will help us in this case, right? So let me just open the index file. Now let's suppose I change the word CI/CD to continuous integration and continuous delivery here. So let's just change here continuous integration and continuous delivery, right? So I've changed the file here Now let me just save this file and let me just close this. Now once I've changed and closed this file, let me just use the git diff command to see the changes. So you can clearly see that this line has been changed. Now what we're going to do is we're not going to add or commit this file. We're just going to stash this file. So as I told you, stashing is a way of creating a checkpoint for non-committed changes. So since we have not committed any change here, let's just stash this change, right? So for that, let me type in the command git stash save, and in quotations, let me type in as feature 2 changed, right? And then I'll just click on enter. So once I click on enter, you can see that it is saved on the working directory, and it also has a message with a particular stash, right? So you know what has been happened there, right? Now, if you have n number of stashes stored in your temporary location, to check how many stashes are present and the particular IDs, you can use the command as git stash list. So this will list all your stashes present in the temporary location. So here we just have one stash. It has a particular ID, that is stash @0. It shows on which branch have we applied the stash, and then it also shows the message related to it. Now, if you want to apply these changes on feature 1, what we have to do is you just have to go back to feature 1. So for that, you'll type in git checkout feature 1, and then you'll open the file index.html. And over here, you can clearly see that it is CI/CD, right? It is not continuous integration and continuous delivery. So you can clearly see that it has not changed on feature 1 branch. Now, if you want to apply this change on feature 1 branch, what you have to do is, without using the gedit option to change it manually, you can just apply the stash that was just created, right? So for that, you just have to type in git stash apply and the stash ID, right? So if you press on tab, the stash ID automatically comes up. And if you have n number of stashes, you can just use the git stash list command, and you can just copy the ID of the stash that you want to apply here, and then you just have to click on enter. So this will automatically make the changes in the index.html file. As you can see clearly that it is showing an output that index.html is modified. So for that, let's just open and see if it is really done or not. So let me just open this file. Well, you can see that it is changed to continuous integration and continuous delivery, right? So that means our stash was successfully applied. Now, well, you clearly saw in the index file that it has changed to continuous integration and continuous delivery. So now let's just commit this change. So for that, let's use the command git commit -m, which will automatically let you include the message. So let's just type in the message that CI/CD has been changed to continuous integration and continuous delivery. So once this is done, this automatically creates a commit that on feature branch 1, you have changed this commit. So this will commit the changes that you have made on the branch feature 1. So guys, this was what stashing was. So basically stashing is used whenever you go forward a few number of commits and then you want to revert back to some uncommitted change. So you just have that uncommitted change stored in the temporary location, and from where basically you can take that particular change and then you can apply that change, right? So that's how stashing helps. Now coming to rebasing, as I told you, rebasing and merging are almost same, but they just do the same thing in different ways. We previously saw how merging can be done by using the git merge option. Now let's see how do we perform the rebasing option, right? So for that, let's create a new branch. So let's me type in git checkout -b and the branch name. So suppose I put the branch name as feature 3, and this will create a branch for me. Now let's open the HTML file and make some changes, right? So let me just open the HTML file. Now let me just make some random changes here. So let's just say I make the changes of Azure to AWS, and then I change the name to Mercurial, and then I save this file. And then let me just add this index.html to commit these new changes. So let me just add index.html, and then let me just commit these changes, right? So let me just type in git commit -m, and then in the message, let me just type in that name was changed to Mercurial, and cloud name was also changed. So once this is done, let me just click on enter, and this commits the changes. Now let's go back to the master branch and let's make some changes there. So let me just type in git checkout master, and then let me make some changes in the master branch, right? So let's say I changed over here to AWS and GCP. So I'll just save this file and I'll close this. Now I'll again commit these changes. So for that, let me just add this file first, right? So let me just add this file and then I'll commit the change. So I'll type in git commit -m, and then in quotations I'll mention the change. So I'll say Azure was changed to AWS and GCP. So you can see on the master branch we have made these changes, right? Now let's edit one more file here. So let's just say I edit the CSS files in the master branch. So let me just check the CSS file. So to list the CSS file, I'll use the command list -a, which will list all the files in the sample project folder. In this, I want to go for CSS files, and then I want a list of all the files, right? So you can see that it has only one file, that is site.css. So now let's go back. Let's edit this file. So let's type in site.css. So let's say I just add a comment here. So for that, let's say this is the CSS file for the web page. I add this comment, I save this file, and then I'll commit these changes. So basically I'll just add this file and also commit these changes. So if you want to do this in one command, you can type in git commit -a for add and -m for mentioning the message. So let's say I mention the message as a comment was added, and then I click on enter. So basically this shows that our changes have been committed. Now what we're going to do is we're going to go back to the feature tree branch, and then we're going to rebase it with the master. So you can see that the master is 2 commits forward than the branch feature tree. So let me just go back to the branch feature tree. So for that, I'll type in git checkout feature tree, right? So this will switch my head to feature tree. Now what I'll do is I'll rebase it with the master, right? So I'll type in git rebase master. So you can see that the changes that we have made to the feature tree have been applied onto the master branch also. So you can clearly see that the tool name was changed to Mercurial and the cloud name was also changed. So this was the commit message that we gave when we made changes in the branch feature tree. So what I'll do is I'll just go back to my feature tree branch and then just check if all the changes made to the master are applied there or not. So I'll just type in git checkout feature tree, and then I'll open index.html, right? So let me just type in index.html, and let's see if the changes made on the master are applied here or not, right? So you can see that the Mercurial services has been applied, and then also we have AWS portal and also AWS and GCP projects shown, right? So all the changes are applied on the index.html file. Similarly, let's check for the site.css file, right? So let's just go for the site.css file. And you can see that there's a comment mentioned here that we mentioned on the master branch. So with rebasing, you can see that all the changes to the master can be applied to the branch. And also you can see that even if the master branch is few commits ahead of the commits of the branch, we can still make the changes made in the master branch affect the branch. So guys, that was a short demo. Now, what we want to do is we want to push the complete local repository to the remote repository. Now, if you want to push the complete local repository to the remote repository, you just have to use the command git push -u origin, that is the variable name that we gave, and everything on master. So when you use this command, you can see that we are asked for the username of our GitHub account. So I'll just type in my username and the password for it. So once it is done, you can see that all the files from the local repository are pushed to the remote repository. So now let me just open my remote repository and show you. So let's just go back. And you can see that our sample project is already there, and you can also see the latest commits in all the files. So that's how you can push your stuff on local repository to the remote repositories. And also similarly, you can also pull everything from the remote repositories to your own local repositories by using the command git pull. Our problem statement of 3 developers having a problem with source code management is solved finally with the help of Git and GitHub. So guys, that was the end of the hands-on part. So now let me just revise all the basic commands that are used in Git. The sudo apt get install git is basically used to install Git. Then you can configure your username and password for the GitHub account. And then git rm file name is to remove any repository. Git add file name is to add a file. Git status is to, as I mentioned before, is to find out how many commits are done, if there are any commits left. Git commit is to just commit the comments. Git log is to know with how many commits are done. Git difference is to understand what is the difference between the local repositories file and what change has been made. Git tag annotation message is basically when you use tags to identify any commits, right? So if you have to work on with any specific commits, like 10 commits back from the present position, then each commit has a commit ID, as I told you before. So you can mention that commit ID to the tag and then you can use it. Git rmf file name is to forcefully remove the file that is present in the staging area. Similarly, git show tag is to just use the tag that you're using. And then moving on, we have git rm cached file name, that is to remove from the cached area. Also, git tag is to create a tag. Git push origin master is to push your local repository to the remote repository. Git pull origin is to pull the data in the remote repository to the local repository. Git add remote origin and remote link is to link the local repository to the remote repository. Git fetch origin is to fetch all the files present in the remote repository to the local repository. Similarly, git push origin tags is basically to push all the tags, that is all the commits that we have made, to the remote repository. And then we have branching and stashing commands. So git branch name is to create a new branch. Git checkout branch name is to change the working head. That means, like if you mention git checkout branch 1, so that the head will change to branch 1. So git merge branch name is to merge masters with the branch. Git branch basically shows the branch that you're working on and all the branches that you have, right? Git branch delete branch name is to delete the branch. Git branch -D branch name is to delete the branch from an unstaged area. Git stash save message is to basically save the stash and the message. Git stash list gives you the complete list of stashes you have. Git stash apply stash ID is like you apply that particular stash on that particular commit. Git stash pop is to apply the most recent stash and then remove it from the stash stack. Then we have git stash drop stack ID, that is used when you have to delete that particular stash from that stash list. And also you can clear the complete stack of stashes by just using this command of git stash clear. So guys, that was a basic overview of basic commands of Git. Well, there are various number of operations with Git, and then you have n number of Git commands. So guys, I hope that you've liked this session. Thank you and have a great day.